We are going to cover classes and objects. I'm sure most of you are familiar with C++ or even Python also. So object-oriented programming is not new to you, but still I will give an introduction to what is object-oriented programming. Or shall I take a poll on, can you tell me if how many of you are new to object-oriented programming? I will stop the screen sharing. Where is it? Stop presenting and layout. Let me put it here. Okay, only those who are new to object-oriented programming can raise your hand. Those who are hearing the object-oriented programming for the first time. Okay, all of you are already familiar. Very good. So let me go little fast then, but you can always stop me in case you don't follow something. Okay, one more thing maybe I want to poll. Was the morning session okay, or was it too fast, or do you think that that was okay? The pace was okay. You can raise your hand in case if you felt the morning, sorry, not morning session, that 6 p.m. session. Was it okay that you could follow? Maybe it may be a repetition for one of you. Can you raise your hand in case if you want to say that it was okay? Okay, so I hear some. Okay, those who feel that any doubts you have, any of you that I need to cover anything, I have those. Anyone you want me to explain something from the morning 6 o'clock class? Anything you want me to repeat? You can tell me. You can chat window, or you can tell me, or you can come online and tell me. Otherwise, I presume that you follow what I said. Okay, thanks for responding back. Okay, where is presenting? No, I don't know how to go back. Oh, yeah. Okay. Okay. So let us start. I think I already started the recording here. Yes. Okay. So I think you are already familiar with classes and object-oriented programming. So let us start with this. We define a template like a class wherein we mention about what are the data, we capture data and operations, or what you operate on this data. These are called methods. Okay, and we define some data which are inside the class, and the methods are used to operate on them, and then we instantiate different objects from the class. So that's basically a class object. Okay, what are classes? A class is a user-defined blueprint or a prototype from which objects are created. Classes provide a means of bundling data with functionality. Functionality means that what operation we want to do on the objects or the data which is stored inside the object or a class. We define those methods. Creating a new class. Okay, in Python, okay, even a class is an object. Okay, when I say class CLS colon maybe pass, this is a simplest class that I can define. This is capital, of course. Now, normally the Python convention is the class name is also in capital to start with, first character. So this itself is an object. Okay, even the class definition itself is an object. Okay, so we can pass across the function or anything you can do. So creating a new class creates a new type of object, which is a type of class type, allowing a new instances of that type to be made. Then that object can be used to create a really instantiation of that class, which are called objects. So that is a object type. And class itself is an object within Python, because Python everything is an object, as I told you earlier. So that also has a memory, and it may be lying in a code area as well as some data common. So each class instance, which is an object, can have attributes attached to it for maintaining its state. So we can create an instance of the object class and then attach attributes to that. Attributes is nothing but the data within the class or within the object. You can have attributes at the class level or as well as at the object level. Class instances, which are objects, can also have methods defined by its class for modifying its state. So methods are used to modify the attributes of a class or an object. Class attributes are the variables that belong to the class. So we have attributes at the class level, as well as when you instantiate it, each of the objects also will have attributes. So they are maintained individually. Now, class attributes are common across any instances you create, but there are some differences, a little bit of nuances are there, which I will explain with an example so that you understand it rather than explaining it. So to be precise, attributes are like data objects within the class. There are class attributes as well as object attributes. Right now, let us understand that, then we'll go into it. And if you are from C++, you know that there are public, private, protected, those kind of access permissions are there. But whereas here, what you define each of them, each variables or attributes or methods, they all fall under public. That means they can be accessed from outside. There is no public keyword, but it's default assumed to be public. An object is an instance of a class. Now, what is an object? What you create is an instance of the class. A class is like a blueprint, while an instance is a copy of the class with actual values. So whenever you create an object, it takes a copy of whatever class attributes you are defined. Okay, you can have some attributes at the class level, which are taken multiple copies, and then you can modify them individually. Then they become a local copy. What is there at the top will remain as a class attribute. Okay, that when you instantiate an object, it takes a copy of the class attribute and maintains its own label, wherein you can individually modify them. That also I will show you with an example to understand that better. So class attributes have some unique behavior when they are changed through class name or through an object of that class. So when I say at the class level you are defining some attributes, then if you are changing it with the class name, you are changing those attributes which are at the class level. But prior to that, if some objects have been instantiated, this change what you make will not be reflected on these objects. Okay, they have made a copy, but that is also not very true. Okay, sometimes if you are not modified it at the object level, then whatever you change you make will be reflected here. But if you make a change at the object level, then whatever change you make later on at the class attribute level, they will not be reflected on the object level. But when you create an object, it takes a copy of them. Later on, if you modify it at the object level, then it leaves the relevance with the connectivity with the class attribute is gone. Then it is maintained at the object level. But if you are not done that, then if you make any change in the class, that will also be reflected. Okay. But if you add any new attribute, that will be visible only when the objects are created after the class has been modified. Okay. That there are some nuances which I will explain it with the example rather than explaining it here. Even if you don't follow now, it's okay. We will see with the examples. So that's the plan for today. So the behavior is also different based on the attribute is mutable or immutable. That maybe we'll cover later classes. Okay. So what I have mentioned, there are methods are also available which will operate on the attributes, and there are two types of attributes. One is at the class level attribute and object level attribute. When you are instantiating an object from a class, it takes all the class attributes with those values, and if you modify it at the object level, then they maintain an individual copy of that, and they refer to the newly modified values at the object level. That will not be reflected at the class level. Okay. There is because of the nature by which this Python itself operates, it is very easy to explain also when we see the example. We will see that. Okay. Now, object creation, one example I will show you. This is a little different from the constructor concept that we have in C++. What happens in C++ is when you do a object creation, the constructor is called and it is creating the object there. Okay. The whatever instantiated object of the class. Whereas you cannot say that init is synonymous to the constructor of C++. It's not that this init function, which is a special magic methods, if you define it inside a class, it is meant for initializing the object that you are instantiating. Now, let me give an example before I even go deeper. Now, imagine I have a person class. I have defined an initialization method that is going to be called after the object is created, not while the object is created or for the creation of the object. It is after the object is created. Now, what I mean by that? Now, when I say person, which is same as a class name, and I am giving some input. Now, what happens is this object is created now when you have a person, when you have this. Now, since you are passing a parameter, it is also matching with the initialization routine that you have written. It defaults calls this method. Okay. Now, this method init underscore underscore expects two parameters. One is a self, which is the object which has been instantiated. Now, currently what has been instantiated? This object is already in the memory and its pointer is passed as a self. And then this person is also passed as another parameter. Now, init is called after this object is created. Now, what are we initializing it with? We are initializing it with the name that is getting passed. Now, this object creation is creating the attribute now, dot name. So inside the object dot name attribute, that is name attribute is created, and this value whatever we are passing is initialized. Person1 is initialized. So to summarize the activities that happen when we do this, I will tell you now. Name is an instance attribute of the class person. Now, what is this name? Name is created with respect to the self. Self is nothing but the object which is getting instantiated, and that is being passed as a first parameter to this method, which is instance method, because it is expecting an instance of the class to be passed as a parameter, first parameter. So what is it doing? It said that it is creating an instance variable or instance attribute with a name, whatever name. Its name is name, ID is name. Now it is getting initialized with this value. So now let us see what is the sequence of operations which I have already explained. Looks up the, now interpreter looks up the definition of the person class, instantiates or creates a new object in memory, then calls the object's init function method, passing this newly created object as self. It has created the object already and it is passing it now, and an argument which has been given it on this particular creation line, wherever it is getting created, and the name variable, name ID is now created, and it is assigned a value, whatever the object person string is, that address is assigned. So stores the value of name in the object. Now value of the name in the object, that means it gives you a value to this name. Okay, why I am saying value here? Because all the variables in the class are defined or maintained as a dictionary, and the ID is the key, and the value of that ID is a value. Okay, whatever is the assigned value. So it is always maintaining like a globals globals is maintaining um, all the variables in the global area as a dictionary. Here also all the attributes of the class or at the object level or at the class level, they are also maintained as a dictionary. Internally, Python maintains as a dictionary. So it needs two values with this two contents. One is name as the key as well as the value. So whatever you pass, person one will be the value and the key is the name. Now after that it returns a new object. Now this itself is returning a new object. So what is getting assigned to this person one? So this is the flow of object creation. I hope this is clear to you. Maybe I thought I will explain this before I go and show what is the examples we'll see. So it attaches the identifier person one to the object. So identifier pointing it. So let us not look at the homework now. It's too early. Okay, now let us look at some examples of class. So simplest, I said we can have this as a definition. So I can create, now let me print type ID of cat. So I mentioned that a class itself is an object in Python. So when you, okay, let me clear it. So what you see here is ID, type and ID of cat is a class type, and it has also got some ID. That means this itself is maintained as an object inside the Python. So I can define a function which accepts class object and it prints class passed. So I can pass this function. I can pass a class itself. I can pass it, and it can be seen there. So now, shall we create? Now we can create an instance of the cat. A cat is cat. This. So we can have this. Now we can type. If I type this, what do I say? We will see that. Now it says that object type. Now you see that its type is object. Both are objects. Class is also an object, but that is of type class type, and then there is an identifier, and you have some identifier here, and it is also an object, is a cat object. Okay, so I hope you understand the difference between these two. This is the object instance and this is the class itself. Okay, that itself is an object again internally. Now let us talk about some attributes. Now I can have without a parenthesis also, that's also allowed. Now let us create a class attributes, which I do it at the class level. So these are all two class attributes. Now let me print it. I said that all of them, all attributes are public, so we can print both of them without any issue outside. I don't need a, oh sorry, what happened? Why I not created the object? Okay, so brown and 2. So what we have done, we are able to access the class level attributes in the object. Now what is happening? here let us try to understand internally what is happening. We have created a class level attribute which are called color and age. Now they have been assigned this string address, whatever, brown, and 2, this object 2. Now when I instantiated the a cat, it got the same color and age with the same value. They are still pointing to the same thing. Now let me do something. Let me change it using the cat itself, cat class name, with using the cat class name. I am going to change it now to black, and then I want to change the age of it also to 20. Okay, just to remember it. Now let me print it. Now what do you think, expect? Okay, what has happened? We have a class attributes which we initialized it inside. So when we instantiated it, it got those values. We printed it and we saw that brown and 2 are there. Now I am printing it again. So let me say that one class attributes of cat. So just to differentiate them. So what did I do? I modified it now, but I did not modify using the cat object what has been there. I modified it with the class name only. Now do I expect the changes to be there or not? Okay, what is your guess? Do you think that whether these changes, whatever I did at the class level, would have been reflected in the object here? Okay.
Yes, sir.
Okay, yes. So it has been done. Now why is it so? Because it is still this, we have a label here at the object level. Maybe I can create a even bcat also. Let me create a bcat, and then so that we will have both 2a 2b. Okay, okay, now this also will have the same thing. Now let us do one thing. I will change a cat dot color to a black. Okay, just to differentiate it. B cat color to b black. Now what has happened? I have modified only these two. Now let me print it. Maybe I should change it to 3. Now we have not touched the other attribute. We have only changed the color attribute. Now A is showing as a black and this is B black. Now if I change again using that class object, okay, now I am doing the color new black, some new black. I am doing it at the class level. I am not changing it at the object level. I am changing it at the class level. Now do you think this will have any changes, impact of this? Okay, now let us see that. Your guess must be that it should not be. Okay, so A black, B black remains the same. This new black, whatever class level I did, now no longer is affecting the object. Now what about the age? Age I am changing it to 21. Now will it impact? Yes, it will impact because I have not modified it. So this will still be pointing at the previous object, and then when I modify that, it gets, all the objects are also getting modified. Now this new black is still changed. In the cat it is changed. Now suppose if I create a C cat with cat, now what will happen is that will have the new value whatever we have modified. Now C cat will get the new color whatever we change at the class level. So new black is there. So what is happening, it is maintaining at the class level attribute, and when it is inherited, sorry, not inherited, when instantiated, the objects also still point to the class level object. They cut off from the changes whatever is happening at the class level once they have been modified using the individual object instances. Okay, once you modify it, they no longer have a relationship, and they become a separate entity. Okay, that's how the class attributes are taken by the objects and then modified. Okay, that's what I wanted to do, show you here. Now, and any other new instances will be taking the current value of the class attribute. So current class attribute is this, and this is the current attribute. So that is what is given to the newly created object. So that's very obvious. Okay, now let us do something more. Maybe I will take it from the, I have made lots of writing, so let me use that to advantage instead of typing. Now I say B cat, I am changing it, and the cat color I am dark brown, some changes. Now B cat color, what will happen, it is changed here, so that will be reflected, but this change will not be impacting it. You will have only this dark brown coming here, not dark black. Okay, that dark brown only will be there, but this cat color will not be impacting the object which is there. Okay, now this is very this is okay. I think I have already declared. Now let me do one thing. How do I create a new attribute? Now add object attribute apart from the class attribute. Now what I do, I have a cat, I am adding a size which was not there earlier, and I am adding it now. And then how do I find out all the attributes of an object? So that's a shortcut available, so we will use that. Where's function returns the dictionary of attributes of a given object. So now what did I do? I modified or added a new attribute, an object attribute size, which was not there, and then I am listing out. Okay, B cat is not there, so let me remove it. Okay, now you see here size medium and color black. So one more thing here, this when it prints only the object attributes, and then the class level attributes are not printed. If you want to see all the attributes, we can do that. Okay, individually you can access it. Okay, let me access that. Don't think that that class level attribute is not available. Now it's still there. Class attributes of a cat. So let me a cat. We saw color, a cat, age. Now size. Now if you individually access them, you get all the values, but when you are using where's, it only prints the age is not printed, which is at the class attribute level, and it prints the color and size. Now a cat, you see here, you get the where's, sorry, only these two are printed, age is not printed, whereas when you print here, age is printed. Okay, when you individually access it, it is getting printed. That means this is maintained at the class attribute level, and where's is accessing only the object level attributes which are modified. Okay, or created new with the object name. Okay, so either you can create it like this or you can create it inside, so we will do that. Now how do I create a new attribute at the class level? I can do this acat new attribute, and then I can print it. So let me take this. Now what I did, cat new attribute, new value. I'm creating now a new cat. All the object level attributes I'm printing. Now let us see whether this is printed there. You won't see that. It prints empty. Okay, because they are all in the class level. We have not created any object level. So the vars only prints the object level attributes, and it gives you empty dictionary. Now let me show you. I create a what I do, I am not creating it. It is already a class attribute, color is there, but I am modifying it. I am with the object name, I am modifying it, and then I am using the vars to print it. Now you see that this attribute is now become an object level attribute, though it was there at the class level. It was not printed here because it is looking for the attributes which are been modified at the object level. So when I modify it with the object name, it becomes the object attribute, and vars gets you that value. Okay, that only this is getting printed. Okay, you can see that you get the object level attribute. Now that doesn't mean that you have lost the this have been copied. No, okay, that doesn't mean that you have lost the age which was there at the class level, but you can individually access it, then you can print it. Okay, it is still there, but var sub function is not printing it for you. It only prints the object level thing. Here you can see that the new color. Okay, I have already I should not have done this. Okay, no problem. One more modification, that value gets reflected immediately. So that's what you see here. Okay, now let me show you one more, just to show you that vars gets. Now what you see, I am modifying age also, which was at the class level attribute, as a object level attribute. Now new cat is going to have a new age, which is not reasonable. It's okay. Now let us print color as well as age. Now color also modified object level it has become. So vars should get both the colors and age getting printed here. Okay, individually I am accessing it. I am also accessing it at the using this vars function. So this dictionary is maintaining all the object level attributes, which this became object level attribute, which was remaining as a class level attribute earlier. Since I modified it, it became an object level attribute. That's all. Okay, so I hope this is clear. Now what about this? So this I mentioned it at the function level. We have a documentation, which is a inbuilt a variable which maintains that documentation. So now I am initializing it. It was not there when I actually defined the class. I did not write any documentation. Now I am writing new documentation for the cat class. Now it was null. Now it is being created. Now if I say help, it should give you all the information about the cat object. Now, sorry, cat class. This is a cat class. It gives you the help, the documentation, whatever I said, it has been printed. It is there, captured there. And then it is maintaining a dictionary of data descriptors, dictionary for instance variables if defined, and list of weak references to the object if defined. Okay, I will talk about that later on. And then data. We have data and other attributes defined here. Now age, color, attribute, everything is there. Okay. Now new attribute. Did I make a new attribute? A new name I have given? Yeah. I have given a new attribute like this. So that's name of the attribute, and color and age. So all of them, it doesn't differentiate between either it's a class level or object level, but all the data area is printed, and with all the values of that is getting printed. That's all. Okay. So this you can look into inside the class what is happening. Now let us do this. Okay, now I am going to add more methods. Init function to create and assign values to it, and then object of instance attributes. During the object creation, we are going to initialize it. Now I am writing some documentation here for this class, and then I have a class level attribute with some value. So we define the class level attribute here, and then init method, which will be called on creation, which is having no other parameter other than the object itself. Then we are creating the object level attribute here. They don't become a class level attribute. They are object level attribute with the self, color, and age. So every instance of the cat will have these two. And then I'm printing a method, another method for a get class level attributes, so that I am getting it back. Now let us use this method now. Okay, pprint pretty print, it is called pretty print. So let me use the pretty print. When you are objects, when you are printing, it will actually make your life easier. Okay, now what are we doing? I am printing the object level attributes, so it should not, this should not get printed in this, but these two are object level attributes which is getting created on init. So it was not earlier there. Whenever init is creating those new attributes, and then class level attribute, we are printing it here. Okay, and we are accessing it using object cat, but because it is there in that object level also. Okay, so this doesn't print the class attribute, but we can access it uniquely, specifically with a class attribute, which I have mentioned already. Okay, now let us go back. Okay, now let me explain this a little bit. Today I think we can finish it early. Okay, now we have a class with this two class level variable, and then in itself I'm printing the type of the self, that's the object type of class X. Then I can create a new class variable also, attribute also, with the class name and cx3, another class attribute. I can create it here. If you want to create a new class attribute, that's allowed here inside the init. Then two object level attribute. Oh, sorry. Okay. And then we have a variable, a new var as another method. Here I am creating a new object level attribute. So now what happens is, if you don't call this method, this variable for this object wouldn't have been created. Okay, when the instance, unless you have called this method, this variable is not created. Whereas these methods, these objects, these instance variables would have been created when you have init. Okay, because object creation itself, but new will not be there. Now let us just check that once. Now suppose if I create an x obj1 equal to x, now print pairs of x obj1. So what does it print? It prints you ix1, ix2 with some values as a dictionary, of course. Okay, so it doesn't print this unless you create it or unless you call that function on that object. So let me now obj1 dot new var Now I have called that method. Now let us print this. Now you see that new is created now. So you can partially create some class object level attributes based on the methods that you are invoking or not. Now I have already written a method. Now what if I am trying to access this self.new, but I have not created a new var? That's a runtime error. Okay. Now let us try to do what is happening. I hope you can understand what I am saying. Now what will happen? Now I am creating the instance of x class x and then calling the print var. Print var is expecting the new to be there, but I have not called this method so far in this case. Now what will happen? So it has no attribute. So this is a runtime error, and this kind of issues need to be handled. Otherwise, we'll have trouble. This I'm highlighting it, but you need to be careful when you do this. So this will create an error when you have an object. When I have a method which yeah. Sorry, go ahead.
Sir, on line 123, there is a x.cx1 which is giving it
Uh,
122.
yeah, yeah. Oh, that is giving error.
That
Yeah, yeah, yeah. You are right. This is also error. Okay, there is one more error. Is it? Let me increase your volume. Okay. Uh, no. Can you come again?
sir, x is not defined. X is class name. Okay, got it.
Got it, no? Okay,
Got it.
okay. Okay, okay. Thank you. So, okay, maybe I will bring, I have not talked about this. See, what we are doing here is we are printing the class level variables. There is no issue when I print it here because these are all, even the cx3 is created here in the init itself. So on the object creation, obj creation, this attribute has been added to the class, though it is not there in this place because this is invoked. So there is no issue of these three, but there is a problem here because these two were there, those attributes were added in the init, but we did not call the new var yet, and then we expect this print var to the printware thinks that the object is having this. When it is invoked with that, it doesn't find that attribute because this xobj1 doesn't have that attribute. So the attribute could be added based on what methods you are calling. I think this is little different from what you have in C++. Okay, there you cannot add attributes using methods invocation. It's the loosely type. Okay, this connected. So you have an issue, runtime issue here. Whereas in this case, there is no problem because we have already called the new var. So the second invocation of print, did I print it? No, I didn't print it. Sorry, I should call that xobj1 dot print var. So if I do that, it doesn't have any runtime issue because I already made sure that the new var is called prior to the calling of this. So this is little bit you need to be aware of and you need to take care also. Otherwise we will get into trouble. Okay. So now let us do one more thing. Now I want to ask your opinion. See, I have maybe another 10-15 minutes, maybe not more than that. Okay, I don't want to take more than that. Shall I complete that? I don't think we need a break now. We can go and complete that because I have the midsummer is coming. I don't want to pump too much things now. Shall we continue? Okay. I'm going to leave you early today. I don't know whether you are happy or sad. Okay. Happy or unhappy? Leaving you early. Sorry? Okay, I'm not hearing because. Okay. Okay. I was also a student. Thank you. So I hope you are following me, whatever I am covering. I don't want to too much. I don't want to give you before the midsum. So let us do that. Okay. Now where I am. Let me. So I will continue and then leave you early. Okay. Uh, what I should do? Okay, this is covered. Yeah. This. Let me take this and then explain you what is happening. As I mentioned, X object is not there. Okay, no problem. Uh, oh, object one. Oh, object one. Okay. Now let me explain what I'm trying to do. Forget about this. This print var was because of the new var was not called, so we are fine. Now we are fine. All variables are there. Now what I am saying is X object dictionary before new var. Oh, okay. Now I should call this before I call the new var. Okay. So let me put it here. I did not call new var here. So what happens when I print the dictionary before new var and then here after new var? So let us print both. Okay. Let me print it first and then I'll explain you what I want to do. Show you. Okay. This is very clumsy. So let me put one. Okay. Now let us look at this. Um, See, all the attributes are put in a dictionary, and like doc variable, this dictionary variable points to the object attributes. Okay, object attributes. So xobj1 and dictionary. So that gives you all that ix1 and ix2 which have been created inside the init. Okay, so it doesn't print new var. Whereas after I call the new var, then that gets also added to the dictionary. So that's how internally it maintains. This should not be there. Okay, you will not get any error here. Fine. This I hope you are clear. All the object attributes are maintained as a dictionary, and the identifier is underscore underscore dictionary. Okay, fine. Now let me take this and explain you, because when I'm not typing everything, it becomes easier for me to complete fast. I hope you are not losing track of what I'm doing. Okay, now let me tell you what I'm doing. New var, why am I calling? Now the object variable new is created. Okay, now let me do some change here. Okay, let me, for fun, let us do something. New val equal to, okay. Oh, no, I don't want to do that now. This is, I don't know what I am trying to do here. I think it is there already. I already copied, so it's no fun here. There is nothing. I don't need to do it. Okay. Now let us take a new class. Let me another small thing we should remember or we should be aware of. So let me tell that. Okay, self is not a keyword. Okay, in Python, whereas this pointer, this is a keyword in C++, but that is not true in Python. So the first parameter is supposed to be the object reference. Okay, it doesn't matter what name you call it with. So you see here I am calling it as a self and then self, doesn't matter as long as I use the same name here it means the same. This actually a label, as far as is concerned, is an identifier which is bringing in the newly created object reference. And when you have that, it is getting passed, and you are creating a new object attribute using that, and you are changing the value. So now what I am doing, the two I have used different names in each of them, and I have created new attributes here, object level attributes with the init, and then I am modifying one of them, x. I am modifying with the class method, and then this method, because I am passing this here, I am calling it as a this here. I am changing the y value here. Okay, so let us now print it. Okay, let me create a new C equal to new class object. Now I have created it. Now print, let me call it as new C attributes. Okay, now what all I should print? I should print new C dot ix comma new C dot iy. So what do I get? I will get ix and iy, of course, no problem. Now let me call on this object dot, what is the name of the method? Class method. Okay, so why am I doing all this? Because I want to show you that it doesn't matter whether you have self or something else. Okay, that's what I'm trying to say. Now I am changing it with some value, something, but it promptly affects the iy. Okay, this class method is changing the ix, so ix modified. Okay, and then iy is iy. Then I will now copy this guy. You know what I'm going to do. I'm going to call this method. Okay. Now this is also modified. It doesn't matter what you are giving. It will be modifying the attribute. Now let me add a new function. Okay, this I am afraid def new method. Maybe let me call it as a new. New equal to, can I do that? I cannot do that. Then let me try. Now what happens? I can't do it. Okay, now I'm getting this and this, so this will not make sense at all, so let me not do that. Okay, I don't know what I'm trying to do, so let me remove it. I don't want to do anything. Now let me print something. Okay, I think I already done this, so let me print the, we are going to almost coming to the end of the class. Now what I do, new class. Okay, this class object I have created, and I am printing where's. Now, okay, one by one I should show, otherwise there won't be any fun. I should not be too fast. So new class is just printing the values. Where's is printing the object ix and ix1, ix1 and ix2. Okay, now let me change this. Okay, now what I'm doing, this object I am changing ix's value. I think I already explained it. I think it's nothing new. So it is getting changed. Okay, where's is, I think I already shown this. Okay, it's nothing new, so I can print it out, no problem. I thought it is something new. Okay, so now I'm calling the class method and this method, and then I think whatever I was typing it there, it is available here. So you will see that the changes have been reflected as you start calling those functions. They get so effectively what does it mean? This first method parameter which is passed to the class is the reference to the object, and which is with respect to that, if I am referring to any new attribute, then it will be created. So maybe I can create a new attribute here, um, clf new attribute, object attribute, let me write it, equal to new attribute. Now I'm printing where I have not printed where, at least I am printing here, so that will get reflected here. New attribute has come here whenever I'm using the vars. Otherwise it will be hidden. If I am not accessing it directly, it will be there anyway. I am not accessing it in this place, but if I use the vars, then all the attributes are printed. So you can add a new attribute also using this, doesn't matter. But caution, do not use anything other than the self in your code. It is changed only to demonstrate that there is no effect, but you have to worry about the person who is going to read your code, and this kind of thing will be really confusing. Please don't do that. Okay, I'm just showing you for demonstration purpose, and say that self is not a keyword in Python and you can use anything. That doesn't mean that you should use. Okay, the convention is to use self here and use self here, so that we are making it clear that we are creating a new attributes of the object which is being created or which is being passed. Okay, please do not do that. That's why I put a caution there, so that you don't do by mistake.